and then plots, view plot, beautiful. All right, so this is the mass density as a function of pressure and temperature. All right, mass density as a function of pressure and temperature. I can go to graph controls, and then I can copy, print plot, print setup. Okay. So if I simulate my CO2 injection well, and I get the flowing bottom hole injection pressure, or if I can also get the reservoir pressure, and I know the reservoir temperature of my reservoir, so I get the pressure, bottom hole flowing pressure, bottom hole injection pressure, or reservoir pressure, and I know the reservoir temperature, so I get the CO2 density at certain pressure and temperature. So if I know the density at that condition, if I know volumetric rate at that condition, then I can calculate the mass flow rate, maybe kilogram per day or tons per day. Okay, so that's the idea. Very easy. So I will go to table, and then I can copy the numbers here and paste the information, paste the results on my spreadsheet, and I can generate my own correlation from the spreadsheet, and I will use the correlation to calculate the mass flow rate from the volumetric results that I obtain from my simulation. Okay. By the way, I need to check the reservoir temperature that I will use in my operation. So the reservoir temperature will be 209. Okay, 209. So we can close a little bit, close first, right click and create stream analysis, property table, design. Okay, if the temperature is 209, then I will use only one temperature as my lower and upper bound. Okay, it's cannot one. Okay, so I will try to use this one. Only one increment, only one value actually. Calculate. Oh, still okay. Performance. Okay, so I can copy everything here. All right, and then paste the table on my spreadsheet. All right, but as you can see, at this temperature, in the range of my pressure starting from 14.5 to even 3000 psia, the phase is in vapor. Okay, I click plots, view plots. All right, so it's the curve, so it's very easy to generate correlation from this curve actually. All right, yeah, so if I only use one temperature, then the result will be like this. It's very easy, right? Okay, by the way, if I know the injection temperature at wellhead, let's say at wellhead it is in 60 degrees Fahrenheit. calculate, check the performance table. No, now some will be in vapor and the rest, yes, some liquid, some vapor and liquid again. So if we check plots, view plot, you see the density. It's quite interesting, right? Okay, so by the way, you get the idea. Maybe we can use specific correlation at this pressure range. And then here, we can also create a correlation at this range and then continue with the third correlation. So we can distinguish three pressure ranges. This will be used to create one correlation, and this one second correlation, and this one is third correlation. This is for 60 degrees Fahrenheit. But of course, you can set as per your temperature. Go back to property table, design, and you use this lower bound and upper bound of temperature, and lower bound and upper bound of your pressure. So that's all. Again, generating fluid properties using HYSYS is really, really, really important and useful. Okay, thank you so much for watching and see you again in the next HYSYS videos. Thank you.